In this video, we want to consider two problems, two similar problems, or we can say same problem. One problem from PMO 2023 national level, problem number 2, and one problem exactly we have that problem in a book. This problem translation is this one, and book name Number Theory, author Mariam Rizakhani, Iranian professor at Stanford University, and published date, this is important, 2004. And again we have same problem in 2023 PMO national level. The only difference is that here it says 2 to the p minus 1 minus 1 over p is perfect square. Here it says this. So if we consider this one is t, this one is what? This one is 4t. So let's see how we can solve this. For this one, we have an important idea, background idea that you should know and is useful also in AMC, BMO, British Mathematical Olympiad. If you want to learn other background ideas that will be repeated again in PMO 2024, PMO 2025, because the ideas will be repeated in AMC, AME background ideas. Important ideas in game strategies, number theory, combinatorics, algebra, and geometry. If you want to learn those background ideas, as I said before, feel free to send message to my WhatsApp number in the description.
I haven't solved it yet. I got to a point, but like I can't.
Okay. So homework 2 is this one. Homework 1 is what? Is I told you prove this part, right?
Yeah, we don't need to go over that. I understand.
Okay, so this one is okay?
Yeah.
Okay, want to solve homework 2, right?
Yeah.
Homework 2 and 3, we proved that they are equivalent, right?
Yeah.
So we can prove only one of them. Agreed?
Yeah.
Okay, so for example, let's prove this one, homework 3, okay? If you want to prove homework 2, you can factor from 4, it will be homework 3, okay?
You know the question is the answers, like 3 and 7?
Yes. You've checked the small cases and you found only 3 and 7, right?
Yeah.
For Pn2, it is not integer, right? Pn2, let me check. 2 to the 1 minus 1 over to 1 half. It's bad. For P3, it will be 2 to this 2 minus 1 over 3, which is 1 squared, right? For P5, we will say, okay, 2 to the 4 minus 1 over 5, 3. It's not perfect square. For P7, we can see it's 2 to the 6 minus 1 over 7, 64, 63 over 7, 9. And if you check other numbers, you will see, okay, only we can find 3 and 7, right?
Yeah.
Okay, now we want to prove if P is not that, let me... Okay, let's check for other P's. Let's prove that it's impossible, okay?
Okay.
So
I made some progress. So
can you explain?
2 to the p minus 1 is px squared.
Exactly. Then what?
Then px squared is 2 to the p minus 1 over 2 minus 1 times 2 to the p minus 1
Exactly. Good job. Yes. It's part of the solution minus 1 because P minus 1 is even, right?
Yeah.
Because P is odd. Good
And
job. Then what?
their GCD is either 2 or 1.
Okay.
And it doesn't work. So
Yes, because they are odd. Let's check. GCD of this and 2 to the P minus 1 over 2 plus 1 is D divides this, D divides this, so D divides their difference, D is 2. D is 1 or 2, but from what, if P is at least what, we can say they are even, they are odd.
2.
Let's check. If P minus 1 over 2 is at least 1, then we can say this one even minus 1 odd, right? Because if the power is 0, 2 to the 0 is 1, 1 minus 1 is not odd, it's even, right? So P at least 3. For P at least 3, we can say they are odd. Understood this part or want me to explain?
The way I did it was say like if you consider the first part each,
Which one? This one A, this one B?
yeah, if you consider it like that,
You
then
want
A
to
is
you
gonna
want to
be
you want to reject 2?
yeah.
Okay. So what's your A, B, then what?
So A equals 2 times x1 squared,
Yes.
but A is also negative 1 mod 2, so it's a contradiction.
Okay. One of them is 2x1 squared. One of them is what?
The other one is 2px2 squared.
Exactly, for example. And you say, okay, this one, A is negative 1 mod. You say A is negative 1 mod 2, you said?
Yeah,
Yes, A is odd, right?
yeah,
And A is negative 1 mod 2 for, do you agree P at least 3 again? Because this one should be 0. You consider this one is 0, right? Mod 2.
right,
So this one is 0 mod 2 when power is at least 1 for P at least 3, right?
yeah.
Okay, what about next case? For example, what about this case that if A is 2 by 1 squared and B is 2p by 2 squared? Sorry, 2y2 squared. What about this case? Again, you said B is 1 mod 2, right?
Yeah,
Okay. So they are saying when you say 1 mod 2 means you are saying it's odd, right?
yeah,
Okay, for P at least. Exactly. So we can conclude D is 1, right?
yeah.
Then what?
So the A is like, for example, m squared.
Yes, 2p1 over 2 minus 1 is m squared and
The other B is pn squared.
pn squared. And pay attention, we don't have m and n. Okay, that's good. What about case 2?
2 to the p minus 1 over 2 minus 1 is pn squared.
P, let's use another one because we've used these. P, for example, s squared, right?
Yeah,
And 2 to the p minus 1 over 2 plus 1 is r squared, right?
yeah.
Okay, could you solve any of these two cases?
For the first case, I got the result that p is m squared plus 2 over m squared, but I didn't know how to prove that no, it's impossible to have anything other than 3 or 7.
For case 1?
Yeah.
For case
So I
1,
just said,
from here, you can reach contradiction if P is larger than something. Can you say that we should consider? Want me to tell you how we can reach contradiction for large? Large P means P, for example, like here. At least 3 here. You can say P is when P is at least something, you can reach contradiction for this part. Want me to tell you how to reach contradiction from this equation, or want to find it on your own?
oh, from there I like continue differently. So
You should
maybe
consider mod a number. If I tell you mod what, then it will be so much easy, and it's not hard to
is
find mod what.
it mod p?
No, mod PV is not good. Another mod. Want me to tell you mod what or want to find it on your own?
Let me try it.
Okay, sure.
Is it mod 3?
Mod 3, what can we say about mod 3?
Um, about mod 3, so m squared is either 1 or 0 mod 3.
Yes, what about left hand side?
Left hand side is 0 mod 3.
Not always 0. 0 or
1.
exactly, because for example, look, 2 to the 1 minus 1, 1, 2 squared minus 1 is 0, right?
Yeah.
Okay, so we cannot reach contradiction because you said right hand side can be 0 or 1. Here 0 or 1. Also, you said this one can be only 0. If it is 0 also, again, we cannot reach contradiction because right hand side also can be 0, right?
Right.
If we consider mod something here, for example, we have some cases here, we have some cases, they don't have any intersection, so it's impossible, right? Want me to
Okay,
tell you mod what or want keep trying?
let me try it again.
Okay, sure.
Could you tell me?
Sure, mod 4.
Okay.
Okay, consider mod 4 and reach contradiction.
So left hand side is always 3 mod 4 and right hand is 1 or 0.
Left hand side is
3
3 mod 4 if P is at this what?
off.
No. Mod 3 is correct, but P should be at this what?
Five.
Because P minus 1 over 2 should be at this what? 2. Because if it is at this 2, then you can say 2 to the P minus 1 over 2 minus 1. Mod 4 is 0 minus 1, which is 3. Mod 4. If this. And this one is equivalent that P is at least 2 times 2 plus 1, 5. Right hand side, M squared. M squared mod 4 can be what?
0 or 1.
Yes, if you check all cases, 0 to 3. 0 squared is 0, 1 squared, 1, 2 squared, 0, 3 squared, 1. So do you agree it's not possible because here they don't have any intersection? Left hand side can only be 3, right hand side can be 0 or 1. So we don't have any answer. So for P at least 5, it is okay. And we checked until P7, right?
Yeah.
So for this part, we reach contradiction. Now for this part, want hints or want to try on your own first?
The same process as the
No. Here different. Want hint?
Okay.
You should pay attention to this equation. Okay? For
Okay.
example, like here that we solved, here this equation. Want me to tell you should do what to this or want to try on your own?
I tried it on it.
Okay, sure.
So 2 to the p minus 1 over 2 is 8k.
Can you say it again?
2 to the p minus 1 is over 2 is 8k.
Is 8k, you said?
Yeah.
Yes, you can say it's multiple of 8 because then what? But you want to consider mod?
Uh, R has to be odd, so
R has to be odd, yes. And mod 8, it will be 1, and also it will be 1, right? We don't have any
yeah.
contradiction. So for this one, want me to tell you what you should do?
Um, well, I found out how like p is greater than or equal to 7, but I don't have to do it.
You found that for this case, p has to be greater than or equal to 7.
Yeah.
Okay, so but there are lots of other cases, right? Infinitely many cases to check, right?
Yeah.
For this one, you should take 1 to right-hand side. So it will be 2 to the p minus 1 over 2 is equal to r squared minus 1. Then we can do what on right-hand side?
R plus 1, R minus 1.
Exactly, r plus 1 and r minus 1. And one more hint, or that's enough?
Uh, can you give me a hint?
Okay, sure. Do you agree the product of these two things is a multiple of 2, is a power of 2?
Right.
So do you agree, for example, this one should be 2 to the a1, this one 2 to the, for example, a2, right? Because the product
Yeah.
is power of 2. And you can consider GCD. GCD of r plus 1 and r minus 1 can be what or what?
2 or 1.
2 or 1. Want to try rest on your own or one more hint?
Let me try it.
Okay, sure.
Okay, so 2 to the p minus 1 over 2 is a perfect square.
Can you say it again?
2 to the p minus 1 over 2 is a perfect square. P greater than 3.
Perfect square is when this one is even, but we don't need that this one be even, right?
Yep. But if all primes other than 2 are odd, so it'll be even for everything. But p
For
equals 2.
everything it is even. For example, for 11 it's not even.
Oh, right.
Okay, and we don't need that this one be perfect square. It is from power of 2, right? We said
Yeah.
this one is power of 2, this one is power of 2, right?
Yeah.
And which one is greater, a1 or a2?
A2.
a2, because it is r plus 1. So a1 should be what or what?
A1.
Because the GCD is 1 or 2.
1 or
Can you tell me GCD of these two things in terms of a1, a2 is what?
A2 minus A1.
No. Let me ask you this. GCD of 2 to the a1 and 2 to the a2 is what?
Uh, the 2 to the minimum of A1, A2.
Exactly. Here you said a1 is less than a2, right?
Yeah.
So it's 2 to the a1, right? So 2 to the a1 is 1 or 2, right?
Oh,
So
okay.
a1 can be what or what?
0 or 1.
Exactly, 0 or 1. Want to try rest on your own?
Okay.
Okay, sure, try.
Okay, so you get P equals 7 for the second case.
P equals 7. Okay, let's check. If a1 is 0, it means that r is what?
R is 1. R is 2.
Yes. So r plus 1 will be what?
R plus 1 is 3.
Which is 2 to the a2. That's a contradiction, right?
Yeah.
When a1 is 1, r is what?
3.
Yes, because r minus 1 is 2 to the a1, 2. R is 3. So r plus 1 is what?
R plus 1 is 4.
Yes, 2 to the a2. So it's 4 times, in this case,
2.
2 to the p minus 1 over 2 is 2 to the a2. A2 is 2 to the a2 is 4. Times 2 to the a1 times 2, which is 8, which is 2 cubed, right?
Yeah.
And this one will be what? P minus 1 over 2 is 3, which p is 7, right?
Yeah.
For this one, we said p is at least 5. So if we check p3, we can find p3 in this case, right?
Right.
Because as you can see, 3 minus 1, 2 over 2, 2. 2 over 2, 1. 2 to the 1 minus 1, 1. It's perfect square. But we consider p is at least 5. So p7 here, p3 here. We prove we don't have any other answer except 3 and 7, right? Okay. So we solved homework 2. Column coloring. I told you I would tell you. Okay. Homework 3.